Dear students, in the previous lectures we covered network parameters. In this lecture we are going to discuss equivalent circuit of a two-port network in terms of network parameters. That means in terms of different network parameters. So let's start with equivalent circuit of a two-port network in terms of Z parameters. So let us see how can we draw the equivalent circuit of a two-port network in terms of its parameters. There are the steps. The first step is we will write the relations of Z parameters, that is the equation of voltage is V1 equal to Z11 into I1 plus Z12 into I2. Similarly, V2 is equal to Z21 into I1 plus Z22 into I2. Next we have to draw the equivalent circuit in terms of Z parameters. So drawing the equivalent circuit means what? In the first equation, that is V1 is expressed in terms of I1 and I2, and two network parameters Z11 and Z12 are involved. So we see first term is Z11 into I1. So Z11 into I1 is nothing but the voltage drop. And when we are representing like a two-port network, so in the case of two-port network, it should be, there will be two ports. At one port there will be voltage V1 and current I1. Similarly, at another port we'll have voltage V2 and current I2. Next, our target is to draw the equivalent circuit in terms of Z parameters. That means we have to represent Z parameters. So how will you represent? See, the term in the first equation is Z11 into I1. So when I1 current is entering to the port port 1, we can see that Z11 into I1 will nothing but the voltage drop at this port. So we can represent simply by an impedance. That means Z11 is represented by an impedance simply. So here we can say that I1 into Z11 is the voltage drop for this network. Next we have another term, that is Z12 into I2. Now see, I2 is the current of port 2. So here when we have to represent the term Z12 into I2, here also we see that Z12 into I2 is a voltage. But since I2 current is not related to port 1, so there is only one way that we'll have to represent Z12 into I2 in terms of dependent voltage source. That's why I have connected a dependent voltage source, and now you can see the value of the dependent source is Z12 into I2. So now when we apply Kirchhoff's voltage law, we can write minus V1 plus I1 into Z11 plus Z12 into I2 equal to 0. From here we get the first equation, V1 equal to Z11 into I1 plus Z12 into I2. So left part is correct. We'll have to remember the direction of dependent voltage source is positive terminal in the upward side, negative terminal in the downward side. Next, where the second equation is V2 equal to Z21 into I1 plus Z22 into I2. V2 is the voltage of the port 2 and I2 current is entering through this port 2. So there are two terms, Z21 into I1 plus Z22 into I2. So see, Z22 into I2 is related to the current I2. Hence we will write first Z22 in terms of an impedance. Then we have another term Z21 into I1. Again we see that for port 2, Z21 into I1 is dependent on the primary current I1. Hence we will have to represent by a dependent source, and its magnitude will be Z21 into I1. And when we look at the polarity of the voltage source, the polarity will be positive in the upward and negative in the downward. Again when we apply Kirchhoff's voltage law, we see minus V2 plus Z22 into I2 plus Z21 into I1 equal to 0. From here V2 is equal to Z22 into I2 plus Z21 into I1. It means it is satisfying Kirchhoff's voltage law. So this is the equivalent circuit of a two-port network in terms of Z parameters. Next, the second topic is equivalent circuit of a two-port network in terms of Y parameters. So first we'll write the equations of Y parameters. The equations are I1 equal to Y11 into V1 plus Y12 into V2. Similarly, I2 equal to Y21 into V1 plus Y22 into V2. Now we have to draw the equivalent circuit in terms of Y parameter. So we see the first equation, it is I1 equal to Y11 into V1 plus Y12 into V2. That means here the voltages are expressed in terms of current. It means voltages are multiplied by corresponding admittances. So here see the first term, I1 equal to Y11 into V1. So Y11 into V1, how can we represent like this? We can write in terms of parallel branch only. That means in parallel branch we see the current I1 is entering through the primary terminal. So here when we connect a shunt branch having admittance Y11, so we can see that Y11 into V1 will be the value of current flowing through this branch. Next we have second term, that is Y12 into V2. So again we see that V2 is related to secondary terminal. It means we will have to replace it by represent it by a dependent source. Now dependent source, what can be the dependent source here? Here the term is Y12 into V2. It means voltage controlled current source. So here we have represented the Y12 into V2 by voltage dependent current source, and the direction of current is downward, because when we apply Kirchhoff's current law, you see that I1 is equal to V1 into Y11 plus Y12 into V2. Similarly, we have to write the second equation, I2 equal to Y21 into V1 plus Y22 into V2. So here we see that across the secondary port we have the voltage V2 and current I2. So we see that current I2 has two terms, one is Y21 into V1 plus Y22 into V2. So first let us see Y22 into V2. When we represent Y22 by a shunt branch admittance, then we can see the current flowing through this one will be V2 into Y22. Now we have second term Y21 into V1. Again we see that the second this term is related to primary voltage V1, hence we will have to replace by a dependent source. So here again I have used one dependent current source, that is Y21 into V1. The direction of dependent current source is the downward direction. So here when we apply Kirchhoff's current law, we see I2 is equal to Y22 into V2 plus Y21 into V1. So this is the equivalent circuit of two-port network in terms of Y parameter. Next, we have the equivalent circuit of two-port network in terms of H parameters. That means in terms of hybrid parameters, we have to write the equivalent circuit of a two-port network. So again we write two equations of hybrid parameters. First equation is V1 equal to H11 into I1 plus H12 into V2. Similarly, I2 is equal to H12 into I1 plus H22 into V2. So again let's start from the left side, that means from primary port. So in the primary port we see that we have voltage V1, current I1. Next, voltage V1 is equal to H11 into I1 plus H12 into V2. So when we see that H11 into I1, so it is nothing but the potential drop. So potential drop means what? It can be represented by a series impedance, and its value will be H11. So I have represented H11 in this network. Then we have term H12 into V2. So here we see that the V2 is the voltage of secondary port. It means here we will have to represent it by dependent source. So here it will be voltage dependent voltage source. Its magnitude will be H12 into V2. Now we can see that primary side the equivalent circuit is completed. When we apply Kirchhoff's voltage law, we get minus V1 plus I1 into H11 plus H12 into V2 equal to 0. From here we get the first equation, that is V1 equal to H11 into I1 plus H12 into V2. Next, come to secondary terminal. We have the secondary voltage V2 and current I2. Next we have to write the equation I2 equal to H21 into I1 plus H22 into V2. So when first we will start from H22 into V2, that means V2 is the voltage of secondary terminal while I1 is the current of primary terminal. So we will start with H22 into V2. So here we see that I2 is equal to H22 into V2. That means current is equal to admittance into voltage. So again, when it comes to represent an admittance, we'll have to use the parallel branch, that means shunt branch. So we have written H22 in the parallel branch. Next we have the second part, that is H21. So H21 means what? H21 means we'll have to represent it by a dependent source, because I1 is depending on I1 is the current of primary terminal. So here we represent it by a current source. Its value is H21 into I1, that is dependent current source. So when we apply Kirchhoff's current law, we can write I2 will be equal to H22 into V2 plus H21 into I1. Again the direction of current will be downward. Next is fourth one is equivalent circuit of a two-port network in terms of G parameters. So G parameters is basically the inverse of H parameters. So we can write the equations. Equation for I1 is G11 into V1 plus G12 into V2, and second equation will be V2 equal to G21 into V1 plus G22 into I2. Now we have to represent these two equations. By using these two equations, we have to draw the equivalent circuit. So let's come to first equation. First equation is current. So when we have to write current in terms of when we have to write current in terms of two different parameters. So current means what? When we are representing current, it means whenever we have to write for current, we will have the parallel branches. So the first branch is G11 into V1. V1 is the voltage of primary side. So G11 is just like an admittance here. So we will represent it by a parallel branch G11. That means it is admittance of G11 is the admittance of this parallel branch. Next term is G12 into I2. So I2 is what? I2 is the current source of current of secondary terminal. Hence to write G12 into I2 here, we will have to represent it by a current source, dependent current source, current dependent current source. So here the current dependent current source is G12 into I2, and the direction will be downward. So when we write Kirchhoff's current law, we will see I1 will be G11 into V1 plus G12 into I2. So this is all about the for the primary part. Now come to secondary port, and at the secondary port we have the voltage V2 and current I2, and we see that secondary port we have to write voltage equal to V2 equal to G21 into V1 plus G22 into I2. When you have to write, when you have voltage in LHS side, it means there in the equivalent circuit the branches will be in series, and if you have current in the LHS side, it means the branches will be in parallel. So here from here it is sure that the branches will be in series. So first is V2 equal to G21 into V1 plus G22 into I2. So first let us focus on G22 into I2, because I2 is related to the current of secondary terminal. So here we can see that G22 can be represented by an admittance. That means it is showing a voltage drop of G22 into I2. Next term is G21 into V1. So since V1 is related to primary side, so we can write G22 into V1 as a voltage dependent voltage source. and its polarity will be upward. Now when we apply Kirchhoff's voltage law in the secondary port, we can see minus V2 plus G22 into I2 plus G21 into V1 equal to 0. From here we get the second equation, that is V2 equal to G22 into V1 plus G21 into V1 plus G22 into I2. So this is the equivalent circuit of G parameters. So when we can conclude from these four parameters the equivalent circuit in terms of these four parameters, we see that whenever you see a current at the left and the LHS side, so it means the network is going to be represented by parallel branches, and when you have a voltage in the LHS side, it means you have to represent the equivalent circuit in terms of series branches. Next is the equivalent circuit of ABCD parameters. So when we talk about equivalent circuit of ABCD parameters, so basically when we write the equation for ABCD parameters, we write the voltage V1 is equal to A into I1. That means we are writing for transmission parameters. So transmission parameters, LHS side there is voltage V1 and current I1, and RHS side will have voltage V2 and current minus I2. So we write V1 equal to A into V2 minus B into minus I2. That means here we see that on the left side you have voltage V1 and right side voltage V2 and current I2. So when we go to draw the equivalent circuit of ABCD parameter, so let's start from primary port. If voltage is V1, next you have two terms, that is A into V2 minus B into I2. So here we see that both V2 and I2 are related to secondary port. We are drawing for primary port and both of these are related to secondary port. So here when you will go to put the dependent source for these two things, you will have to take two constants. So it is not possible to take two constants simultaneously. Hence we cannot write the equivalent circuit for ABCD parameter. Similarly for A dash, B dash, C dash, D dash parameters, that means inverse transmission parameter, again you will have to make two constants simultaneously. It means you cannot draw the equivalent circuit of ABCD parameters and inverse ABCD parameters. Rest of the parameters you can draw the equivalent circuit, that is for S parameter, G parameter, Z parameter and Y parameter. So this is all about the equivalent circuit of two-port networks in terms of different parameters.